High above the Earth in the stratosphere, a powerful force of nature swirls. This is the polar vortex, a vast area of low pressure and frigid air. It encircles the polar regions, acting as a giant refrigerator. The polar vortex has a crucial role to play. It keeps the coldest air trapped in the Arctic, influencing weather patterns across the globe. During the winter, the vortex is typically strong and stable. It keeps the Arctic frigid and helps drive milder weather in lower latitudes. The vortex's strength isn't constant. It fluctuates throughout the year. These fluctuations can impact the severity of winter weather in many parts of the world. In recent weeks, scientists have observed an interesting phenomenon. The polar vortex, a large area of low pressure and cold air surrounding the Earth's poles, has been behaving in an unusual manner. The polar vortex has been unusually strong and stable, maintaining its structure and intensity far longer than typically observed. This strength is due to a combination of factors. These include lower than average temperatures in the stratosphere and a persistent area of high pressure over the Arctic. The stratosphere, the second major layer of Earth's atmosphere, has seen significant cooling, which has contributed to the vortex's stability. This strong polar vortex has contributed to the relatively mild winter experienced in some parts of the northern hemisphere. Cities that usually brace for harsh winter conditions have seen unseasonably warm temperatures, leading to snowless streets and people enjoying outdoor activities without the usual winter gear. It has effectively kept the coldest air bottled up in the Arctic. The Arctic region, known for its extreme cold and icy landscapes, has retained its frigid temperatures, while the cold air has not spilled southward as it often does. This might seem like good news, but such extreme conditions can have unforeseen consequences. The stability of the polar vortex can lead to disruptions in typical weather patterns, potentially causing extreme weather events in other parts of the world. Scientists are closely monitoring the situation. They are using advanced technology and models to track the vortex's behavior and predict its potential impacts. They want to understand how this unusually strong vortex might influence weather patterns in the coming weeks and months. The data collected will help meteorologists make more accurate forecasts and prepare for any sudden changes. The atmosphere is a complex and interconnected system. Changes in one part of the atmosphere can lead to a cascade of effects in other regions, influencing weather patterns globally. Changes in one area can have ripple effects across the globe. Understanding these connections is crucial for predicting and mitigating the impacts of extreme weather events, ensuring that communities are better prepared for what lies ahead. The polar vortex isn't invincible. It can be disrupted by a phenomenon known as sudden stratospheric warming, or SSW. SSW events are triggered by the upward propagation of atmospheric waves from the lower atmosphere. These waves carry energy that can rapidly warm the stratosphere, sometimes by as much as 50 degrees Celsius or 90 degrees Fahrenheit, in just a few days. This dramatic warming can weaken the polar vortex. In some cases, it can even cause the vortex to split into two or more smaller vortices. When the polar vortex weakens, the tightly contained cold air can escape. This escaping cold air spills southward, bringing frigid temperatures to lower latitudes. Scientists are closely monitoring the polar vortex for signs of a potential reversal. A reversal occurs when the winds within the vortex weaken and change direction. This can happen gradually or suddenly, often as a result of a sudden stratospheric warming event. A reversal of the polar vortex can have significant impacts on weather patterns. It can lead to a weakening or even a complete breakdown of the polar jet stream. The polar jet stream is a fast-flowing river of air that helps to steer weather systems across the globe. The polar jet stream is like a rope, a dynamic and powerful force that plays a crucial role in shaping our weather patterns. It acts as a boundary, separating different air masses and influencing the movement of weather systems across the globe, separating warm air to the south from the colder air to the north. This division is essential in maintaining the balance of our climate, ensuring that each region experiences its characteristic weather. When the polar vortex is strong, the jet stream tends to flow in a relatively straight path from west to east. This steady flow helps to keep weather patterns predictable and stable. However, when the polar vortex weakens or reverses, the jet stream can become wavier. It can dip further south, bringing Arctic air with it. These southward dips in the jet stream can bring outbreaks of cold air and winter storms to regions that are not accustomed to such extreme weather. This phenomenon can lead to significant disruptions in daily life, affecting transportation, agriculture, and even energy consumption. The jet stream's wavy pattern can also cause weather systems to stall out, leading to prolonged periods of cold, snow, or rain. This stalling effect can result in extended periods of unusual weather, such as prolonged cold spells or heavy rainfall, which can have far-reaching impacts on the environment and human activities. Understanding the behavior of the jet stream and its influence on weather patterns is crucial for meteorologists and climate scientists as they work to predict and mitigate the effects of extreme weather events. By studying these patterns, we can better prepare for and adapt to the changing climate, ensuring the safety and well-being of communities around the world. The impacts of a disrupted polar vortex and a wobbling jet stream are not always immediate or direct. The atmosphere is a complex system, and changes in one area can have ripple effects across the globe. These effects can take days or even weeks to manifest. For example, a sudden stratospheric warming event over the Arctic might not immediately cause a cold snap in the United States. However, it could set in motion a chain of events that leads to a southward shift in the jet stream a week or two later. This shift could then bring Arctic air and winter storms to the eastern United States. The recent strengthening of the polar vortex has caught the attention of meteorologists and weather enthusiasts alike. This powerful atmospheric phenomenon, characterized by a large area of low pressure and cold air surrounding the Earth's poles, has been particularly active this season. Adding to the intrigue is the potential for a sudden stratospheric warming event. This occurs when rapid warming in the stratosphere, the second major layer of Earth's atmosphere, disrupts the polar vortex, often leading to significant weather changes. These developments have raised questions about the outlook for the rest of winter in the eastern United States. Could we be in for a season of extreme cold snaps and heavy snowfall? While it is still too early to say for certain what the impacts will be, meteorologists are closely monitoring the situation. They are analyzing vast amounts of data to make more accurate predictions. There is a possibility of more frequent or intense cold air outbreaks. These could bring frigid temperatures and potentially hazardous conditions to many areas. Additionally, winter storms in the coming weeks could be more severe, with heavy snowfall and strong winds creating challenging conditions for residents and travelers alike. The degree to which the eastern United States experiences these impacts will depend on a number of factors. Each of these elements plays a crucial role in shaping the weather patterns we experience. These include the timing and intensity of any sudden stratospheric warming events. If such an event occurs, it could significantly alter the weather patterns, leading to more extreme conditions. The exact track of the jet stream is another critical factor. The jet stream, a fast-flowing ribbon of air high in the atmosphere, guides weather systems and can influence the movement of cold air masses. Changes in the jet stream's path can lead to prolonged periods of cold weather or sudden shifts in temperature. Finally, the amount of moisture available in the atmosphere will determine the potential for snowfall. More moisture can lead to heavier snowfalls, while drier conditions might result in less precipitation but colder temperatures. As we move through the winter season, staying informed and prepared for these potential weather changes will be crucial. Whether it's stocking up on supplies or planning for travel disruptions, being ready for whatever winter has in store can make all the difference. Despite the challenges, winter also brings opportunities for joy and togetherness. From building snowmen to cozying up by the fire, the season has its own unique charm. So, while we brace for the possibility of a chilly outlook, let's also embrace the beauty and wonder that winter brings. The polar vortex is a dynamic and ever-changing force of nature. Its strength and behavior can vary significantly from year to year, influenced by a complex interplay of atmospheric factors. Scientists continue to study the polar vortex and its impacts on weather patterns. They use advanced computer models and observational data to improve their understanding of this fascinating and important phenomenon. While the polar vortex can bring challenges, it is a vital part of our planet's climate system. By studying and understanding the polar vortex, we can better prepare for and adapt to the challenges of a changing climate.